Hi, welcome back to 15-Minute Maths. If you're doing homeschooling or you just want to boost your maths skills over the next 10 weeks, 10-week course, 15 minutes of maths, 4 times a week. This is week 1. This is Friday's 15-Minute Maths. So good luck. What we do is we have a look at the questions, we pause the video, and then when you think you're ready, you have a look at the solutions. There's 15 questions. This is the first 8. So you can pause the video and have a go at the first 8. Come back for solutions when you think you've done them. Then here's the next questions. 15 minutes, 15 questions. Pause the video again. Have a go at those. And then I'll be going through the solutions. So straight into it. Here we go. I left a bit of a solution up there by mistake, but never mind. Let me just erase that one and give you a bit of a head start for some of you. There we go. So let's have a look. Something a bit different here. So missing digits. You've got to find the missing digits in the first 3. If you didn't realize that, you might want to pause the video now and try and complete that. But if we look at this, what have we got? Something in the units plus 6 must be 3. Now, that doesn't make any sense unless we're carrying. So, yeah, 7 plus 6 is 13 is what we're looking for there. And in the tens, 5 plus the 1 plus how many more? 3 more tens to make 9 tens. Well done if you got that one right. If you're unsure how these work, you might want to press pause now and just review your answers to question 2 and 3 before moving on. 7 plus something is 5 again. That doesn't make sense unless we're doing some carrying. 7 plus 8 would be a number ending with a unit digit of 5. So 7 plus 8 is 15. And there's no hundreds digit here. There's no empty box and there's no hundreds digit. So we're looking for 7 hundreds plus the 100 plus another number of hundreds has to be a single digit. So I think it's 7 plus 1 is 8 plus 1 more is 9 is the only way to do that. So 17 plus 78 is what we were looking for there. A subtraction, a number, subtract 4 is 2. That could be 6, couldn't it? So let's put that there. And then here, again, there's no hundreds digit. It's just a missing tens digit. So 2 tens take away some number of tens is a single digit. 2, the only one that's going to work, 0 wouldn't work because we wouldn't write 0, 4 as a number. So I think it's 2 tens take away 1 10 is 1 10. So 26 take away 14 is 12 was the missing digits there. Very well done if you got that one right. Back to something more traditional, I suppose. 7 units take away 1 unit. 6 units, 2 tens take away 5. You can't do that, so we're borrowing from the 40. So we're borrowing 1 from 40, so 39 is left, borrowing the 1. So now we have 12 tens take away 5 tens is 7 tens. 9 hundreds take away 6 hundreds is 300. And 3 thousands take away 2 thousands is 1,000. Very well done if you got that one right. So multiplication, here we go. 4 nines are 36. 4 sevens are 28 plus the 3 is 31. 4 eights are 32 plus the 3, 35 again. Very well done if you got 3,516. Some of you may have been finding 3 digits multiplied by 2 digits a bit tricky. Don't worry. After 10 weeks of this 15-minute maths, you'll be nailing this every single time. We'll do the 9 first of all. So 9 multiplied by 4. 9 fours are 36. 9 eights are 72 plus 3 is 75. 9 twos are 18 plus 7 is 25. Now we're going to multiply by this 3, but it's not 3, it's 30. So we need a 0 in the units to start with, and then we can just carry on as if it's a 3 because we've dealt with the 30 part already, and the columns help us out here. So now we can just say 3 fours are 12. We can say 3 eights are 24 plus the 1 is 25. And we can say 3 twos are 6 plus 2 is 8. So we have 6 plus 0 in the units, 5 plus 2 in the tens, 5 plus 5 in the hundreds, and 8, 9, 10, 11 in the thousands, 11,076. Very well done if you've done that. Division, I'm asking you to always think about short division, not long division, just to try and do some mathematical thinking in your head. So 4s into 5 go once, remainder 1. 4s into 18 goes 4, because 4 fours are 16, with a 2 as a remainder. 4s into 22. 5 4s are 20 with a remainder of 2, and 4s into 28 is 7. Very well done if you got 1,457. Right at the bottom, I'll just move it up a little touch, I think. Yeah, that's better. 6,084 divided by 9. 9s into 6, can't do that, but 9s into 60. 5 9s are 45, so that's not right. 6 9s are 54, and we're looking at 60, so 6 9s are 54. There's a remainder of 6. 9s into 68. 9s into 68, 7. 7 9s are 63 with a remainder of 5, because 63, 68 is a remainder of 5. And 9s into 54 is 6. Again, so 676. Well, that's taxing my brain there, the pressure of videoing myself and getting that one right. So there's our answers for the first day. Incredibly well done if you've done those. Let's move up to the next questions. You can pause now if you want to do them in 2 parts. There's nothing wrong with that, I suppose. I do suggest timing yourself just to get a track of how long it's taking you to do these. You could try and do as much as you can in 15 minutes, or better still, maybe just see how long it takes you to do all of the questions, and then to see if your time reduces over this 10 weeks. I think it probably will as you build your skills. Let's go through the answers here. 300 times 40. Well, 3 4s are 12, and then it's not just 3 4s, is it? We've got some hundreds, and we've got that 10. So there's 3 kind of zeros there, multiplying by 10, multiplying by 10, multiplying by 10. So 12,000 is our answer. 5,200 divided by 100. Dividing by 100 is like moving all the digits 2 spaces. So that would just be 52. And I know that some people would take dividing by 10 again, something like that. That's another method I've seen used. Here we go. We're using that idea of BIDMAS, BEDMAS, BODMAS, depending on where you are learning mathematics in the world. But we know that multiplications and divisions come before additions and subtractions. And I've asked you to underline what you're doing first and to work down the page as we do in high school mathematics as much as possible. So let me do what I know to do first. Divisions first. 18 divided by 3 is 6. We haven't dealt with that 7 or that addition, and the answer is 13. Here we do multiplications before addition, so let's underline them. 4 8s are 32, 5 6s are 30, but we haven't done that addition yet, and it's 62. Very well done if you've remembered those rules again. Find the next 2 numbers in the number sequences. Here we go. 11 15 19, 23. Can you spot what's going on here? Yes, we're adding 4 each time. So adding 4, we get 35 and then 39. Very well done. What are we doing here? We're subtracting, but what are we subtracting? I think we're subtracting 9 each time. So the next will be 28 and then 19. That's subtracting 9 each time. There we go. And the last 2 questions are always going to be a bit problem solving. So I'll move them up like this so I can do some solutions underneath. I'll change these. We've had a time question and then a kind of a situation where you're counting a number of things that are kind of joining of a group of 2 people. We'll change that in week 2 and change these around a little bit as we progress through the 10-week course. This is just week 1, so we'll keep it roughly the same so you get more practice. A time question. You're starting a bike ride at 7:20 a.m. There we go. Nice and early. It lasts for 2 hours and 43 minutes. So let's think about what we could do. Well, we could add 2 hours on, couldn't we? 2 hours. We could add 2 hours. This is how I just like to think about this. We could add 2 hours on, so that's going to be 9:20 a.m. So then all we've got left to add on is 43 minutes. Well, I know that if I want to add up, my tip was to go to the nearest hour. Now, 9:20 up to 10 o'clock a.m., I know that's 40 minutes. And so you're going to have to add on just an extra 3 minutes, aren't you? So add 2 hours, add the 40 up to 10 o'clock, and then just add 3. So I think our answer is 10:03 a.m. Very well done if you got that right, and nothing wrong with just writing out a little bit of working here with some movements on to these times. And the key thing is working up or working with whole numbers of hours and working up to the whole hours themselves if you go past those hours, and just writing and scripting a little bit of working to help you. If you can do it all in your head, fantastic, really, really good. But I like to just do a little bit of writing and working out. Last one. Janie has 14 more trading cards than her friend Giles. Altogether, they have 96 cards. How many cards do they have each? Now, I've shown you this before, but there's a wonderful little method, a visual method I do really like, which I've seen in Singapore maths kind of training and textbooks I've seen before. So Janie has more cards than Giles. So you just draw out a box, and that signifies how many cards that Janie has. And Giles has got a number of cards, but he's got fewer cards. So you just draw a box, which is some number fewer. And these squares that I'm working with on my paper, they're not representative of any numbers. This is just a visual representation of the problem. And so you know that the difference between the number of cards that Janie has and the number of cards that Giles has, this space here, this is 14 cards. There you go, there's 14 cards difference. This is Janie's cards, this is Giles' cards. Okay, so what could we put in there? That's Janie, and that's Giles. Okay, and we're told that in total they have 96 cards altogether. So hopefully this visualization will help you see that if we subtract that 14 from the number of cards in total, so if we do 96 and then we take away that 14, we get 82. So what does that tell us? Well, it tells us, take away the 14, it tells us that this section of Janie's cards and this section of Giles's cards together must be 82. And I think the only way that can possibly happen is if they're both 41 cards. And then the 14 is that part there. Maybe I should have put the 14 in the bar like that. Was that probably easier? Why didn't I do that? There we go. So you can see now, I think it's the final bit of work you could script is something like 82 divided by 2, because there's two sections which are the same in number, and that's 41 each. We can check it out, can't we? Look, 41 plus 41 is 82, plus the 14 is 96, and that makes sense. So I think that visual representation is a really, really nice, clever way of doing it. And yes, we've got that from Singapore Maths Learning. So there we are. That's 15 minutes maths. That's the third one of the week. That's Friday. Very well done for sticking at it. There'll be 10 weeks. If you're homeschooling and your parents homeschooling want some extra maths practice, here it is. All the solutions, all the answers are there, so you can just watch the video, pause it, do the maths, and then check your answers here on Preppy Maths. Thank you very much. It does help if you like and subscribe, so please could you do that, and I will see you next time. Thank you. Bye-bye.